Okay, so good afternoon to all. Let's wait 1 or 2 minutes so other participants can join. Where are the others? Okay, so what we learned actually in the last lecture. So we derived the equation of the pitch factor in the last lecture, which is Kp, or you can say it is also known as the coil span factor. Okay, it is also known as the coil span factor Kc. So you can denote that either Kp or Kc, which is known as the pitch factor. That I already told you about. That pitch factor is also known as the coil span factor, and it is denoted by Kc. So in some of the reference book it will be denoted by Kp. In some of the reference book it is denoted by Kc. So both are same. Okay, so while we are saying if you are using some of the reference book, if it is written like that Kp, or it will be written like Kc, so both are same. So we derive the equation of the pitch factor. So when we have a winding of a full pitch or a short pitch, then that pitch factor is useful. So actually the equation of the pitch factor, it is nothing but you can say it is the ratio of the EMF generated in a short pitch coil to the EMF generated in the full pitch coil. So we are deriving the equation of the EMF. So EMF which are generated in the full pitch coil, it is ER is equal to 2E. Okay, it is ER is equal to 2E, and we are deriving the EMF which is generated in short pitch coil. So when we have a short pitch coil, we are not having the arithmetic sum. Instead of that, we have the phasor sum. So you can see there is some angle between the EMFs which is generated when we have a short pitch coil, and that angle denoted by the alpha. So here we are showing that value, and from that we are deriving the equation of a reference EMF, which is generated in a short pitch coil. So which is 2E into cos alpha by 2, and then we have to use that particular equation of the Kp or the Kc. So EMF generated in the full pitch coil to the short pitch coil to the EMF generated in a full pitch coil. So the final equation which we are getting is Kp or Kc is equal to cos alpha by 2. And then we are modified the EMF equation which we have. Generally, when we are assuming that my coil is full pitched and the concentrated, okay, not distributed and not short pitched, then we have the equation of EPH which is known as the 4.44 F5 TPH. 4.44 F5 TPH. Here F is the frequency, 5 is the flux per pole, TPH is the turn per phase. Okay, so it is turn per phase. But suppose if we are assuming that my coil is short pitched and it is distributed, then we have to modify our sorry, then we have to modify our equation of the EMF which is generated per phase, which is generated per phase. So now we have to multiply the generalized EMF equation with the distribution factor and pitch factor. So I'm multiplying here Kp and Kd. So this is the final equation of the EMF per phase, which is 4.44 F5 TPH into Kd into Kp. And then we will learn one of the example. Suppose I have to calculate the distribution factor and pitch factor, so I have to find the value of Kd and Kp. So for that, it will given that we have 36 slots, 4-pole single layer 3-phase winding, which coil span is starting from 1 to 8. So we have the equation of Kd, which is sine m beta by 2 in divided by m sine beta by 2. So m is nothing but slot per pole per phase. Beta is my slot angle, which is 180 degree by n, and n is nothing but slot per pole, which is known as the pole pitch. So from that, we can find the value of m also, and we already find the value of beta also. So my beta is 20 and m is 3 in that case. So I'm putting that value on the equation of the Kd, which is the distribution factor. So we are getting the value of Kd, it is 0.9597. And also we have to find the value of Kc. So here you can see my pole pitch is 9. So my coil span must be 1 to 9. But here it is given is 1 to 8. So my coil is short pitched by 1 slot. And we have the equation of the alpha, which is equal to the beta into number of slots by which coil short pitched. Beta into number of slots by which coil is short pitched. So my alpha is equal to beta into my coil is short pitched by only 1 slot. So into 1. So here my alpha is equal to beta. So my alpha is equal to 20. And I'm putting that value on the equation of Kp. So my Kp is equal to cos alpha by 2. So it is cos 20 by 2. So cos 10 it is 0.9848. So this is the equation which we are solving in the last lecture. Now today also we have to solve the examples. Okay, so I request if anyone having a calculator with them, you sit with the calculator. Okay, and if it is not available with you, use the calculator which is available in the mobile. Okay. So up to this, anyone having any doubt? Anyone having any doubt? Okay, so now let's solve the example again. So I'm writing down the data here. Okay. I'm writing down the data. So my for the another example. So let's see. Suppose we have a three-phase star-connected alternator. Okay. We have three-phase star-connected alternator, which having the following data. You can say we require the voltage. Okay. When we are not connecting any load to the alternator, then it required to generate a 4000 volt at 50 hertz, and the speed is 500 rpm. Speed is 500 rpm. We have armature slot per pole per phase equal to 3. We have slot per pole per phase is equal to 3. We have conductor per slot is equal to 12. Okay, we have 12 conductor per slot. So now what we have to calculate? What we have to calculate? We have to calculate the number of poles. We have to calculate number of pole and flux per pole. So I have to calculate the P and phi. Okay, I have to calculate the P and the phi. And we have to assume that or here it is given that my winding is distributed and full pitch. Okay, so these are the data we have. These are the data we have. What we have to find? We have to find the number of pole and we have to find the flux. So which are the equation we have? So this is the data. Let me write down that data here. So what I have three-phase star-connected alternator. That should be generate the voltage at 4000 volt. It having a frequency of 50 hertz with the speed of 500 rpm. It having a armature slot per pole per phase. We have 3. We have 12 conductors per slot. We have 12 conductors per slot. And then we have to find the number of pole and flux. Number of pole and flux. So let me write down the data here. Suppose the voltage generated, which is the line voltage, which should be 4000 volt. I have a frequency of 50 hertz. As I already told you, the speed is nothing but when we have a synchronous motor or synchronous machine, the speed is always a synchronous speed. So my synchronous speed is 500 RPM. The slot per pole per phase. So we are denoted slot per pole per phase with M. So M is my slot per pole per phase. So here my M is equal to 3. And we have conductor per slot, it's equal to 12. Okay, it's equal to 12. Now what we have to find? We have to find the P and flux per pole 5. And here it is given that my coil is full pitch. Full pitch, what that means? My pitch factor for the full pitch winding is 1. So my Kp is equal to 1. Okay, that you have to assume, that you have to identify. If my coil is short pitched, then you have to find the value of Kp or Kc also. But once it is right, given data that your coil is distributed or your winding is distributed in full pitch, then you have to identify the value of Kp and Kd. Here my coil is full pitch. So that's why my pitch factor is equal to 1. Now, can anyone tell me how we can find the value of pole, or from which equation we can derive we can find the value of P? Okay, from which equation we can find the value of P? Can anyone tell me about that? You can also unmute yourself and give me the answer if you want. Okay, you can give me the answer in chat also, or you can give me the answer by unmute yourself. From which equation we can get the value of P? Yes, Ashley.
I think your question is how to get the P.
Yes, how to find the value of P, number of poles, simply.
Yeah, we can use the formula of NS is equal to 120 times.
Very
over.
Yes,
So
okay. Okay, very good.
So frequency is there, NS is there, or so we can find.
Yes. Okay, so that's only my question. So we can find the value of P. So we have one equation of the synchronous speed, which is Ns is equal to 120 F by P. That equation is given by the S law. So what we have to find? We have to find the number of poles simply. So I have a P. So I'm interchanging the value of P and Ns. So from that equation, from the equation of synchronous speed, I'm getting the equation of pole P is equal to 120 into F divided by Ns. So now just I have all the value. 120 is constant. My frequency given in the data is 50. and the speed which is given in the data, it is 500. Okay, so it is 50, 510, and this 0 is cancelled out, this 0 is cancelled out. So from that equation I am getting the number of pole P is equal to 12. So this is the first answer. So my pole, number of pole is equal to 12 directly. Okay, so just you do that. If there is example of 6 marks or 7 or 8 marks, you are easily get 2 marks. Okay, now only another thing remaining that we have to find is phi, flux per pole. So can anyone suggest another equation, or anyone can tell me from which equation we can find the value of phi? Do not unmute yourself for another chatting. If you know the answer, then unmute. Okay, that's why I am not giving the rights for unmute, because someone talking to another and why unmute themselves. Yes, Eslu. Yes.
I think we can use the formula of MF equation.
Yes. Okay. So we can use the formula of EMF. Okay. So the equation of the EMF, just I am writing down here, which we have E phase, EPH is equal to, just we are getting that formula. It is 4.44 F5 TPH KP KD. So from this equation, we are aware about the 4.55, it's the constant, F is constant. KP, we know that here we are using the full pitch coil. So from that, we can say that my KP is equal to 1 for the full pitch coil. So KP I have. So what we have to find, first of all, we have to find the value of TPH, we have to find the value of KD, and we have to find the value of EPH. So first of all, E phase. So here we are aware about that my line voltage is given a 4,000 volt, and my machine is star connected. Okay, so can anyone tell me what should be my phase voltage? Okay, if we have a star connection, I think you have already studied that star delta connection in the first semester.
Zero times E line, I think.
What, E line into or E line divided by?
Zero 3 times E line.
Okay.
E phase over root 3.
See, my actually, yes,
E
it's,
line over root 3.
yes, it's divided by. Okay, actually what we have the when we have a star connection, then my line voltage is equal to the √3 times into my phase voltage. But here I want to find the E phase. So my E phase is equal to my line voltage divided by √3. So line voltage we have, it's given in the data, it is 4,000 divided by √3. So can anyone tell me the value? Well, I have to calculate 4,000 divided by √3. Let me calculate. Okay, it is. Answer is given in the chat by Hegos KU and Sawan also. 2309.4. So now we are getting the value of EPH also. So from this equation now EPH are known, 4.44 are known, FI known, 5 we have to find. Now we have to find the TPH and KD. So first of all, now let's find the KD. So which is KD is the distribution factor. So KD is equal to, we are aware about the equation, which is sine m beta by 2 divided by m sine beta by 2. That's the equation of KD, which is the distribution factor. Here we do not have to find the value of pitch factor because here my coil is full pitch. So now m we know, it is given in the data. It is the slot per pole per phase, and it is given that it is 3. So the value of m it is known, but value of beta that we have to find. So beta is my slot angle, and its equation is 180 degree by n. Okay, you have to use all the equation to find the phi. That is 180 degree by n. So again, n is what's n? N is the slot per pole. So there is a relation, we can find the value of n from the n. N is slot per pole, m is slot per pole per phase. Okay. So we can say from this equation, we can say my m is equal to n by phase. So if I am multiplying my phase with a n, then I am getting the value of n. Up to this, anyone having any doubt, you can ask me a question. Okay. You have the right to unmute yourself and you have the right to give the query in a chat. So any query you can ask me. Okay. Simply what we have, m is equal to slot per pole per phase, n is equal to slot per pole. So thus this slot per pole I am putting here. So m is equal to n by phase. So I want to find the value of n. So n is equal to phase into m. So my n is equal to m is 3, and we have 3-phase machine. So phase is also 3. So from that I am getting my n is equal to 9. N is equal to 9. And from that I am getting the value of beta. Beta is equal to 180 degree by 9, which is 20 degree. So here what we are getting, just let me write down. My m is equal to 3, my n is equal to 9, and my beta is equal to 20 degree. So put the value of beta and the value of m in the equation of KD. So my KD or distribution vector is equal to sine m beta. So m is 3 into 20 divided by 2 divided by 3 into sine beta by 2. So I think that it is the same value that we are deriving in the last session. See, same equation. So my KD is equal to 0.9597. Okay, so now KD is also known. So what is the remaining part is turn per phase, TPH. So how can anyone tell me how we can find the turn per phase? So here there is one data is given that in the example we have conductor per slot. Is equal to 12. Okay, so per slot we have 12 conductors. Per slot we have 12 conductors. So first of all, we have to find total conductors, then we can find the total turn. Okay. Per slot we have 12 conductors. So we have to find, first of all, how many slots are there. So from that, from which equation we can find the number of slots. Suppose I want to find total number of slot. How I can find the total number of slot? So we have one equation of M. N is nothing but my slot per pole. So I want to find total slot. Okay. So N is equal to slot per pole. So I want to find, suppose total slot. So my slot is equal to N into pole. Now you have the value of N. What is the value of N here? 9. Pole we already find. What is the value of pole? 12. So just write down here N is equal to 9 into my number of pole is 12. So we have total 108 slots in our armature. Okay, we have our total 108 slots in our armature. And how many conductor per slot we have? 12. So total conductors is equal to 12 into number of slot. So is equal to, you can say 12 into 108. So what should be the total conductors Z? 12 into 108. What's the answer? Okay, 1296. Okay. So my total conductor, overall total conductor of the armature is 1296. 1296. Okay, that's the total conductor we have. But what we have to find here, we have to find TPH is pending. So per phase we require the value. So first of all, we have to find total conductor per phase. So Z is the total conductor. So ZPH means conductor per phase is equal to the Z by number of phase. So my number of conductors, overall total conductor is 1296. We have overall 3 phases. So 1296 divided by 3. What should be the value? Okay, 432. So this is the total number of conductor we have. This is the total number of conductor we have. Okay. So now what we have to find? We do not have to find ZPH. We have to find TPH. So can anyone tell me what should be the value of TPH? Turn per phase. What should be the value of TPH? Let me show you. You are forgetting all the things. So now we are talking about the conductor. So here average EMF per conductor. So actually we have to find per turn. So 1 turn is equal to 2 conductors. 1 turn is equal to 2 conductors. Okay. So TPH is equal to nothing, but it is the ZPH divided by 2. It is the ZPH divided by 2. So conductor per phase we have, it is 432. Divide by 2, so it is the turn per phase. So ZPH divided by 2, so 432 divided by 2, so it is 216. 216. So now we have the value of TPH also. We have the value of TPH also. So now what we have to find again, let me write down the equation. EPH is equal to 4.44 F5 TPH KD KP. So from that equation, I have to find the value of phi. So phi is equal to EPH divided by 4.44 F TPH KP KD. Just put all the values. So EPH, what we have find, EPH is equal to, yes, 2309.4. So 2309.04. So 2309. Sorry, not 04, it is 0.4. Okay. Divide by 4.44 is constant. F is my frequency 50. TPH is my turn per phase. Just we are getting it is 260. My pitch factor is 1 as I have a full pitch coil. And KD is my distribution factor that we find 0.9597. Now tell me the value of phi. Okay, so the answer given by the Savan and the Hegos and the Eslo, it is 0.05. One minute. Let me also calculate. Yes. So it is 0.05 Weber. Okay, it is 0.05 Weber. Okay, Ashley. So this is the example. From which we can find the value of pole and phi. It can be asked anything. It can be asked to find the slot angle. It can be asked to find the pole pitch. It can be asked to find the distribution factor. It can be asked to find the pitch factor when it will be a short pitched. Here it given full pitched. That's why we have Kp is equal to 1. Okay. So this is the example. If anyone having any doubt, what you can ask me a question. So what we have to find? We have to find the pole and flux. So for pole, we have the equation of the synchronous speed. Ns is equal to 120 F by P. So from that we can find the value of number of pole. So the EMF, and for flux we have the another equation, the EMF per phase, which is 4.44 F5 TPH KPKD. So from that we can find the value of 5, but we do not have the value of turn per phase. We do not have the value of distribution factor, and we have the line voltage. We do not have the phase voltage. So from line voltage we can get the phase voltage as it is a star connected, and if it is a delta connected, then we have a line voltage is equal to the phase voltage. Okay, then we do not have to divide or multiply it with anything. Then we can find the value of distribution factor, and then finally we are finding the value of turn per phase, and putting all the value on the equation. Finally we are getting the value of flux per pole, which is 0.05 Weber, and you can also convert that into a Weber. Then it should be milliweber. Then it should be a 5 milliweber. Okay, so this is the example. So up to this, if anyone having any doubt, you can ask me a question in chat. Okay, so I request all of you, please write down your enrollment number in a chat session for the attendance. And once you fill the data, if you want to leave, you can leave the session. So thank you everyone for attending the session. Have a good day.
સર
Yes.
કાલથી કોલેજ ચાલુ થવાની કે નથી થવાની?
No, from next Monday we will start the offline classes. Next Monday. Tomorrow is the Thursday already.
सर
And
जीटीयू ने ऐसा अलाउ कर दिया सर ऐसा ऑफलाइन क्लासेस के लिए?
it's not compulsory. The
हाँ
lecture will be on hybrid mode, so it should be online and offline mode. It's not compulsory.
ओके सर, मतलब जो हॉस्टल में वो आ सकते हैं ऐसा?
हाँ, हॉस्टल में वो आ सकते हैं, जिनको आना है वो आ सकते हैं, अगर नहीं आना है तो घर से ऑनलाइन भी पढ़ सकते हैं.
ओके सर.
It's depend on student, sir.
Yes, it's depend on student. It's not compulsory for all.
Okay, sir. Sir, we want sir offline classes, sir.
Okay. Yes, Monday से होगा start. Okay, anyone is pending, please write down your number in chat. So, okay, and I will end this meeting if anyone is pending. And if you already fill the data, if you want to leave, you can leave the session. Okay, so thank you everyone. Now I'm end this meeting for everyone else. Thank you.